I'm Anil Kumar. Welcome to my series on statistics. In this video, we'll relate box and whisker diagram with mean and standard deviation. We'll approximate the value of mean and standard deviation using different types of methods, and also we'll come up with some easy to use formulae. I've taken two examples here, and the idea is to estimate mean and standard deviation from box and whisker plots. In case you want to learn from me, you can always send an email to the address given. Also, check our new videos on the website. The two examples which you can see here, we have drawn the box and whisker plot. The one on the left side, which I'm pointing out, and let's say 1, is where you can see a kind of symmetry. Median or the second quartile is right in the center. The whiskers are almost of equal length. In the second one, the box and whisker diagram shows that the more amount of data, 25 and 25, the first 50% is towards the left, and there are many values distributed, rather dispersed more on the right. Now, this kind of data, which is shown in 2, could be plotted as, as kind of like this. You see, where the focus is that the dispersion on the right hand side is more. So, in the case 2, what we expect here is that the mean is greater than median. Since there are some values here in the fourth quartile, and this being dispersed more, stressed towards the right, the mean is on the right side of median, right? So, in this particular case, where the plot could be kind of like this, as you see, the central value, which is mode, the most frequent, and then we have mean, median, and the mean will be slightly on the right hand side. Now, this kind of information or the data distribution is also referred to as right skewed distribution. So that is our second example. Well, you could also have a left skewed distribution where a similar method can be followed, and the basic understanding will be that the mean for the left skewed distribution will be on the left side of median. So I hope you've understood the two type of data distributions which we are talking about. Now the first one here is called the normal distribution. Here the mean and the median are exactly the same values, correct? Because it is the central value, correct? So in this particular case, we're talking about a normal distribution where mean and median lie in the center. Now standard deviation can be estimated as 3/4 of interquartile range for a normal distribution. So the standard deviation will be a point which is approximately 3/4 of interquartile range being difference between Q1 and Q3. 34% of the data is between the mean and the median, between the standard deviation. So that is to say that if, let me again sketch it here, a normal graph here. let us say this is the normal distribution. In that case, the mean is right in the center, the standard deviation, one standard deviation away. The amount of data here between these two is actually the same as the amount of data one standard deviation towards the left. So this amount here is, this area, I can say, is 34% approximately. Okay. So that's what we mean, that the standard deviation is one standard deviation away from the mean will mean that we are looking into the data which is 84%. Correct? So 84% of the data is between the mean, it is up to mean plus standard deviation. So 34% of the data is between mean and standard deviation. So both sides 34%, right? From the symmetry, since we have assumed this to be a normal distribution. So based on this assumption, we are going to estimate the value of mean and standard deviation from box and whisker diagram. And the concept here is, if the data is right skewed, in that case mean will be slightly more than the median. And that means the standard deviation will be further away on the right hand side. Correct? So with this assumption, we'll move forward and try to calculate the mean and the standard deviation. So let's take the first example, which is based on the normal distribution. Correct? So we'll estimate the mean and standard deviation from box and whisker plot. And here, what we have is a normal distribution. So the box diagram here, the median is right in the center, that is Q2, and the whiskers are of equal length, right? So what we see is that the median and mean are equal. So from here, we know that the second quartile median is at 60, and that really means that the mean and median are same, and therefore the mean in this case is going to be 60. So we get the value of mean as 60. Now, we need to find the value of standard deviation. Standard deviation could be found in a couple of different ways. So, method one. Now, depending on situations, you could use different methods. So, method one is to approximate the standard deviation as 3/4 of interquartile range. So, first we find the interquartile range. Interquartile range, as you know, is between Q3 minus Q1, that difference. Q3 in this case is 80 and Q1 is 40. So 80 minus 40 is 40. Standard deviation is 3/4 of this interquartile range. So we can calculate this as 3/4 of 40. That gives you a value of 30. So this is method one, which can be applied to approximate the value of standard deviation. Now the other method, which I'm saying method two, is to see that this is a normal distribution. So normal distribution, as we had been talking about, will be a bell-shaped curve as shown here, where we're expecting mean to be right in the center, and the standard deviation will be such that the amount of data will be 34% more, right? This is the position at 50% for the mean, correct? So this position will be 84%. You get the idea. So mean is right at the center, where 50% is on the left and 50% on the right, since the mean is same as median for a normal distribution. Now in this case, 34% higher is the position for the standard deviation. That means the data where we're talking about mean plus the standard deviation will be 84% of the data, correct? So in this case, the third quartile represents 75%, right? So we have 25% data here, 25% in the second quartile, 25% in the third quartile. So we are looking for a value which is representing 84%. 84% really means that this should be 9%, correct? So 75 plus 9 gives you 84%, and that's what we have done. So we're saying that the sum of mean and the standard deviation, which is slightly higher than Q3, we need 84% position. So it'll be 80, which is Q3, plus 9 over 25 over times the number of data elements in this. So in this case, we are assuming uniform distribution. To calculate, strictly speaking, it is not really uniform, right? Since you can see from the curve that it is not really uniform. So we are approximating, and therefore we are approximating. But uniform distribution gives you upper limit. You get the idea. Uniform distribution gives you the upper limit in this particular case. Since there is more data towards the left than towards the right when we have assumed the normal distribution. So, well, there are 25 from 100 to 80 in the fourth quartile. This represents 25% of the data, right? So this also represents 25% of data. We're looking for 9% value, right? We're looking for 9% value. So 9 out of 25 times 100 minus 80. So that gives you a value which is 27.5. So in this case, we do get a value of standard deviation which is 27.5. Now these two values are approximate values. Assuming 3/4 means 75%, correct? So that was a higher value. So here it is not 68% on either side, but it is actually much higher. So this is a higher estimate. And that seems to be for a normal distribution, another higher value. But you could estimate this to be close to 27.5 or 27, correct? So, but maximum will be 27.5. So that becomes a more accurate estimate as far as the calculations are concerned, correct? So that is how we could actually estimate the standard deviation. So we can say in this particular case that the mean is equal to same as median, which is 60, and the standard deviation is 27.5. Is that clear to you? So I have shown you this value of 3/4 as a rough estimate. Correct? So that is how you could do some calculations and get to the required value. Right? Now, let's see what happens when we have the information which is right skewed. So here we have another box and whisker plot, second case, in which we are considering the right skewed distribution. That is to say that the 25% information which is in the fourth quartile has been stretched towards the right. So here in this particular case, as I was discussing, the distribution will be kind of like this. So clearly, the value of the median, which is, let us say here we have median, then the mean will be right. So that is the median, then mean is going to be on the right side because of extra values stretched in the fourth quartile. So this whisker on the right is longer. That gives results into this position, correct? Now the question here is, refer to the box and the whisker plot to estimate the value of mean and standard deviation and justify your answer. So we have given you options here to match. So from the given value, the options are, if the mean is 7 and standard deviation is 3.75, is that the correct combination? Or is it 7.45 and 3.32, 8.25 and 3.90, or 8.68 and 3.88? So these are the values. Which one is closer to the given situation? That is what you need to estimate. Now let's look back at the characteristics of right skewed distribution. So we know that the mean is greater than the median. We also know that 84% of the data is up to one standard deviation from the mean. So what we are trying to say here is 84% is that generally the median will be the central value, correct? So 50 plus 34 is 84, right? So it is greater than, first is mean is greater than the median. So median is 50, so mean will be greater than 50, right? So 50 plus I am writing, since mean is greater. Median is the 50th value. Mean is greater, so 50 plus, so this will be slightly more than 84%. You get the idea, right? So if you translate that into percentile, then that is how you could do it. And that is a way to easily do it. We also learned another method is that is 75% of the 75% of the interquartile is okay. So here we are saying 75% is up to Q3. So Q3 really represents 75% of the data, right? So this is at 75%, correct? So that is well known, right? We are looking for 84%, so 84 will be somewhere here. So we're looking for a value which is slightly more than 9%. We can take this as 10% for easy calculations. You get the idea, right? So what we are trying to say here is, since the value is slightly towards the right, so instead of 9 which we took in our calculations earlier, we are taking 10% for an estimate. So Q3 gives you 75%, correct? Plus 10% will give you 85%. So that is slightly more than 84% for an estimate, right? So it's not a bad estimate at all. So Q3, the value which you can read from here is 10. So we written 10 for Q3 and then 10 over 25 of the values distributed 15 minus 10, which is 5, gives you a value of 12. So that means that the sum of mean and standard deviation is 12. So this gives you sum of mean, and standard deviation. That is to say, if you add these values, then it is around 12. That is what we are trying to say. Correct? And 10% higher instead of 9%, we've taken approximately the place where we expect the standard deviation plus mean, right? Now, using these combinations, if you add 8.25 and 3.90, what do you get? You get 5, 2 and 9 is 11, and then we get 12.15, correct? So 12.15 is closest to what we estimated, 12, and therefore that becomes a good combination. So if the mean is 8.25, we can calculate the standard deviation also. So in this case, mean is 8.25 and standard deviation becomes 3.90. If you add the other two terms, this is higher, much higher, correct? And this one is much lower. Therefore, they are not the right estimates. So from a multiple choice question, this approximate calculation really helps in estimating the correct combination. I hope that makes sense. So we can summarize this observation in short as that mean plus the standard deviation could be calculated by using the value of Q3 plus 10 over the number of elements within the highest point and Q3, which actually gives you 25% of the information, right? H minus Q3. So that gives you the number, which is the sum of mean and standard deviation. So that is the estimated value. And this equation can help us to get the right solution, in addition to the other small formulas which can help you estimate individual value of mean and the standard deviation. So I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.